Hello students, welcome to your own channel with your Maths Ma'am. Let's see what we are doing in today's video. We are doing chapter 2 which is polynomial, and today we are doing its exercise 2.3 and this is the part number 5 of this series. Okay, let's see what we are doing in this exercise. See children, in this exercise the main concept which we are learning is the remainder theorem. Let us see what is this theorem is. Let Px be any polynomial of degree greater than or equal to 1 and let a be any real number. If Px is divided by the linear polynomial x minus a, then the remainder is P of a. Okay, I will explain you this theorem with an example. Then you can easily understand what this theorem is saying. This theorem is saying Px is a polynomial of degree greater than or equal to 1. Let us take this polynomial x square plus 2x plus 4. Right, the degree of this polynomial is 2. So this polynomial, according to this theorem, the degree should be greater than or equal to 1. So here I have taken the degree 2. Okay, now suppose I want to divide this polynomial by x plus 1. Right, so according to this theorem, remainder would be P of minus 1. Now children, from where I am getting this minus 1? X plus 1 is the divisor. You have to put this divisor equal to 0 and from there you will get the value of x. So x is minus 1. So when you put this minus 1 in this polynomial, you will get the remainder. Okay. Now I have put it here minus 1 in this polynomial. So I am getting here minus 1 raised to power 2 plus 2 minus 1. Wherever I am having x in this polynomial, I will replace it by minus 1 so that I can directly get the remainder here. Minus 1 raised to power is 1. Multiply them, you will get minus 2 plus 4. Right? Now this is equal to, you can see here, 1 plus 4 is 5, 5 minus 2 and this is equal to 3. So this is your remainder, right? So without using the long division method, directly you can find out the remainder of any polynomial when you dividing that by the linear polynomial. See children, this is a linear polynomial. How you can say this is a linear polynomial? Since the degree of this polynomial is 1, that is why it is called a linear polynomial. So with the help of this remainder theorem, you can find out the remainder directly when you divide any polynomial by the linear polynomial, right? Okay, let us start with the exercise now. Your exercise is first question. See children, there are many parts. Okay, so I'll try to do 2 or 3 parts and I will leave 1 or 2 parts for you so that you can also revise this concept yourself or you can try these questions yourself. Let us start with the first part. This is a polynomial, so we will assume that let Px, the name of this polynomial is Px, right? When you divide this polynomial by x plus 1, you are dividing this by x plus 1, right? So it means using remainder theorem, because directly we are using the remainder theorem to find the remainder. Okay, so what is the first step to find the remainder? You have to put this divisor equal to 0 in the side and from there you will get the value of x. So using remainder theorem, remainder would be P of minus 1. Children, see, that is why I have given the name to this polynomial, because I have to show here what is the remainder equal to. So if there is no name, if I have given here, then how can I show it that remainder is equal to P of minus 1? Okay, now you have to put minus 1 in place of x in this polynomial. So you are getting here minus 1 raised to power 3, 3 into minus 1 raised to power 2 plus 3 into minus 1 plus 1. Okay, let us continue with this. Now you have to simplify it. Multiply them 3 times. When you are multiplying odd number, you get always minus. So this is minus 1 raised to power 2 means plus 1. Plus 1 when you multiply by 3 is minus 3. 3 multiplied by minus 1 is minus 3 plus 1. Plus 1 and this is will be cancelled. Now what you are getting here? You are getting minus 6. So this is the directly remainder you are getting using the remainder theorem. Okay children, let us do one more part. I can think I am doing this fifth part for you. Now this fifth part is you have to find out the remainder when you are dividing the polynomial px by 5 plus 2x. So I will first of all put this divisor equal to 0 and here I will get x equal to minus 5 by 2, right? So this x equal to minus 5 by 2 I will put in the polynomial and I will get the remainder. Therefore remainder equal to p of minus 5 by 2. Now this was my polynomial children. In this polynomial now I will place minus 5 by 2. Okay, so minus 5 by 2 raised to power 3 minus 3 minus 5 by 2 raised to power 2 plus 3 minus 5 by 2 plus 1. Now you have to just simplify this expression and you will get the remainder. Okay, let us simplify it. Minus 5 by 2 you have to multiply 3 times. So it is minus 5 by 2, minus 5 by 2 and minus 5 by 2, right? Then minus 3 and again you are multiplying this by minus 5 by 2 2 times. And then 3 you are multiplying by this. So I am directly multiplying 3 minus 5 is a minus 15 by 2 plus 1. Now children, I will multiply these 3 and then I will multiply these 3. Whenever you are multiplying more than 2 terms, so first of all you see the sign 1, 2, 3. 3 times minus. So in the product the result would be minus, negative. So 5 into 5 into 5 will be 125. 2 2s are 4, 4 2s are 8. Here you can multiply 3 minus, again you will get minus. 5 5s are 25, 25 3s are 75 and 2 2s are 4. Minus 15 by 2 plus 1 upon 1. Now you can take the LCM of that, you will get 8 minus 125 minus, when you divide 8 by 4 you will get 2, 2 multiplied by 75 would be 150. 8 divided by 2 equal to 4, 4 15s are 60 plus 8 divided by 1 is 8, 8 multiply 1 is 8. Now you have these three negative numbers, so you can add them. So when you will add them, this is 5, 6 plus 5, 11, 11 or 2, 13. 1 would be carry here, 335 plus 8 upon 8. And this is your negative. 335 means you can subtract 8 and you will get 320, this is 7. And this is minus and this is upon 8. Now these numerator and denominator you cannot cancel because this is an odd number and this is an even number. So this will be your answer. Children, in this way you can try all the questions. See, I have tried here 2 questions, right? If you want, I can try one more question from here. But children, these are very, very simple questions and you have to try this question yourself. Okay, let me do one more part from there. Let us take this part, third part. Okay, because you can see here you are not getting any value of remainder. Okay, now this is the third part. When you are dividing px by x, so this is your divisor, so put x equal to 0, right? So x की वैल्यू आपको क्या रिप्लेस करनी है? आप 0 से. आपका जो पॉलिनोमियल था अब उसको मैं रिप्लेस कर दूंगी जहाँ जहाँ पर भी x है 0 से. तो रिमाइंडर इक्वल टू, you can see the polynomial in your book, p of 0, right? So I have a expression x cube that is 0 की पावर 3 plus 3 into 0 की पावर 2 plus 3 into 0 plus 1. Okay children, now you have to just simplify it. It is very simple now. Sorry. Now I will simplify it here. 0 raised to power 3 is 0. 3 multiplied by 0 is 0 plus 0 plus 1. All of you know when you multiply any number by 0, you can directly write down here 0. So this is 1. So आपका remainder क्या आ गया यहाँ पे 1. This is your answer. Children, these are very simple question. You can try it yourself. Rest of the part you can try it yourself. Let us see the question number 2. Find the remainder when this is divided by this. So you want to divide this polynomial by this divisor. So as we have done in the first question, we will assume let px is x3 minus ax square plus 6x minus a. You want to divide by this polynomial by x minus a. So put x minus a equal to 0. Here you are getting x equal to a. Now using remainder theorem, you always have to mention using remainder theorem, because you are using the concept of remainder theorem, so you have to mention here. So how you are getting the remainder? So using remainder theorem, remainder would be p of, now in place of x, what you have to write down? This a, p of a. Now put this value here, a cube minus a into wherever x is there, you have to replace it by a square plus 6 into a minus a. So this is a cube, a multiplied by a square. See children, here the power is 1. Whenever you are multiplying the two exponential numbers and their base are same, you can add their power. So 1 plus 2 is 3. A raised to power 3 plus 6a minus a. Plus a cube minus a cube would cancel, and this is 5a. 6a में से when you can subtract 1a, you will get answer 5a. This is your answer. Okay, this is very simple question. Let us do the last question of this exercise. The last question is, check whether this is a factor of this. It means this is a polynomial and you want to check that this polynomial is a factor of this. So we will assume let px is a polynomial 3x3 plus 7x. Okay? If you want to check that this is a factor, it means this polynomial should be divisible by this. If 7 plus 3x is a factor of px, then remainder should be equal to 0. Because if you know, if you are dividing 4 by 2, right? So when 2 is a factor of 4, then remainder is always 0. The same concept you are applying here. If this is a factor of this, so when you divide this by this, the remainder you will get 0. So here directly you are checking that whether you are getting remainder equal to 0 or not. So first of all we will find out the remainder. For finding the remainder, you have to put this divisor equal to 0. So here I am putting this 7 plus 3x equal to 0 and x is minus 7 by 3. So remainder would be p of minus 7 by 3, and here you can simplify it. These are very simple questions, children. The same concept you are applying in all the questions, right? 3 into, so minus 7 raised to power 3 means minus is multiplying 3 times. So answer में भी आपके पास minus ही आएगा. Okay, let me write it down here 3 times so that you will not get confused. So this is 7 multiplied by minus 7 3, so 7 into 7 upon 3. So 1 3 will cancel with this 3, 7 7s are 49, and 49 ko when you multiply by 7, 63, 7 4s are 28, and 6 34. So this is your minus 343 upon 3. See, 3 minus odd number of times when you multiply numbers, so you always get in answer in minus. 7 7s are 49 upon 3. Okay children, so let me scroll my sheet. Okay, now you have to simplify it and you have to subtract this number. So there is 3 3s are 9. This is not 9, it is not 3. Now take the LCM 9. Here you are getting 3 4 3. 9 divided by 3 is 3. 3 when you multiply by 49, you multiply by 3. 3 9s are 27, 4 3s are 12 and 2 14, 147. Both are negative numbers, so you can add them. So answer would be negative. 7 plus 3 is 10, 0, 1, 4 4 8 or 1 9, and this is minus 490 upon 9, and this is your answer. Now since the remainder is not equal to 0, you are not getting the remainder 0. So it means if remainder is equal to 0, then only you can say that this polynomial is a factor of the given polynomial. But here you can see remainder you are not getting 0. Since, see children, here if this is a factor of this polynomial, then remainder should be 0. Here I have calculated the remainder, but the remainder is not, you are getting 0. Here the remainder is not 0. So it means, so this is implies 7 plus 3x is not a factor of px. If you will get the remainder equal to 0, then only you can say that this is a factor of this polynomial. Since the remainder is not 0, so it is not a factor of this polynomial px. I hope you understand this whole exercise, right children? Now you can try all these questions again, one time again yourself. If you like this video, please like it and share it with your friend. Thank you for watching this video. Bye bye.